All right, welcome to Mr. P Helps with Math. This is our Welcome to Calculus with Applications first lesson, Unit 0, lesson number 1, day number 1. So in this lesson, we're going to be solving linear equations and exponential equations, absolute values, and doing it with inequalities, actually solving with inequalities. So in the very first question here, this is section 0.1. So we're going to solve it similar to how you would solve solving equations. The only difference is that when you have linears, like this is, 3x minus 4, you're going to have to flip the sign when you're multiplying or dividing by a negative. So just like an equation, I'm going to separate it into two halves. I'm going to solve it just like an equation. So I'm going to add 4 to both sides, and that's going to give me 3x is less than 9. Then divide both sides by 3, and we're left with x is less than 3. Meaning that there's an infinite amount of answers that you can plug in. You can plug in any value of x that is less than 3, and you'll get a true answer. If you use 3, it's not going to work, because 3 times 3 is 9, 9 minus 4 is 5, and 5 is not less than 5. It has to be something less than 3 for it to work. Now, there is that special case when you have dividing or multiplying by a negative, like what's going to happen over here. So I'm going to add 10 to both sides. Pen doesn't always work. Negative 2x is less than 12. All right, then I'm going to have to divide both sides by negative 2, which is the flipping of the sign. So less than becomes greater than. So we're left with x is greater than negative 6. So this time, there's an infinite amount of answers. Anything that's greater than negative 6, meaning like negative 5, negative 4, negative 3, or technically it could be negative 5.9. Then all of those are answers, correct answers. All right, example number 2. This time we have a quadratic equation. So solving it a little bit different. We're going to solve it just like you would solve in a quadratic equation. First thing you're going to do is set the equation equal to 0. Well, in this case, it's inequality. So I'm going to move all of these items over to the left. So I'm going to subtract x from both sides, subtract 6 from both sides. All right, so this is not the best way it should work, but I'm trying to do this in a rushed fashion. So that's x squared minus the x taken from both sides, and then minus the 6. Here we go. So minus the 6 is less than or equal to 0. All right, so next thing I'm going to do is factor this. I'm looking for two numbers to give me negative 6 when multiplied, but also adding up to negative 1. So that would be negative 3 times positive 2. All right, so negative 3 times positive 2. So negative 3 times positive 2 is negative 6, and when I add them, I get negative 1. So this is the same thing as this if you FOILed it. Now, what I'm going to do here is I'm going to solve this as if it was equal to. So x minus 3 is equal to 0, and what I'm looking for are those 2 points. Because I know it's or equal to. So I'm going to add 3 to both sides, and that gives me x equals 3. Solve it over here. X plus 2 is equal to 0, and then I end up getting negative 2 as my other answer. So on a number line, if I were to make one, so I've got negative 2 here, I've got 3 here. I know these are answers, so I'm going to put solid dots here. Now, what's going to happen here is either all of the answers in between the points are going to be possible solutions, or it's going to be everything on the outside. And this is where I need to start testing. So I need to pick numbers that are in between to the left and to the right and see which ones are going to be possible solutions. And that's going to end up telling me my solution set in the end. So the easiest one to test would be 0. So if I make x 0, and I plug it into, now I can plug it in here, I can plug it in here, here. I'm going to choose the factored form. I think that would be the easiest. So I'm going to replace x with 0. So that's 0 minus 3 times 0 plus 2 equals 0. So we're looking for whether or not it's less than. All right, so is it less than or equal to 0? So 0 minus 3 is negative 3. And if I multiply that by 0 plus 2, which is 2, that gives me negative 6. And that is less than or equal to 0. So yes, that is a solution. So I know everything in between I'm just putting a check there, so that means all of this in between is going to be a solution. Now, if I click anything on the outside, it should not work. Like if I make x 4. So if I put in 4 minus 3 and then multiply it by 4 plus 2, is that going to be less than or equal to 0? Let's find out. So that's 1. 4 plus 2 is 6. 1 times 6 is not less than or equal to 0 because that's 6. So that does not work. Same thing goes if I use negative 3. So if I say x is negative 3, and then I put negative 3 minus 3, and negative 3 plus 2, okay, is that less than or equal to 0? So that's negative 6. That's negative 1. A negative times a negative is a positive. So that is not going to work as well. So 6 is not less than or equal to 0. So our only solution is all the numbers between negative 2 and 3, but also including negative 2 and 3. So it's going to be including, which means we use brackets and not parentheses. So here is our solution set. So we've got negative 2 and then comma 3 and putting it in brackets. That is our solution right there. Now, if you use parentheses, once again, that means it's not including that point, but it is including because it's or equal to. All right, so on the next one, very similar process. So it looks like we have a quadratic again, so I'm going to need to rewrite this. So we've got x squared minus 3x minus 10 is greater than 0. So all I did really is move everything on the right side to the left side. So now I'm asking myself, is there some sort of way to factor this? So we've got, looks like x minus 5 times x plus 2 is greater than 0. So then set each one equal to, so x minus 5 equal to 0, and we get 5. And then x plus 2 equal to 0, and we get negative 2. So on our number line, so those are our two numbers that we have. So we have 5 and negative 2, and obviously a lot of numbers that are going to be in between those numbers. So the next thing that we're going to want to do is we're going to want to test those numbers. So something in between, I like to use 0 when possible. So if I say that x is 0, so 0 minus 5, and I'm going to kind of do this a little bit quicker just so that, that I have enough time in this video to finish. So 0 minus 5 is negative 5. And if I multiply that by 0 plus 2, which is 2, is that going to be greater than 0? So I put equal to, so let me erase that back. So is that going to be greater than 0? So negative 5 times 2 is negative 10. Negative 10 is not greater than 0. So that's not true. All right, so that proves to me that nothing in the middle is a solution. So what if I choose something that's over here to the left? So that would be something like x equals negative 3. Negative 3 minus 5 more is negative 8, and negative 3 plus 2 is negative 1. Now, a negative times a negative is going to be a positive, and anything positive is going to be greater than 0. So that part checks out. All right, so I need to test just one more, so I'm going to choose 6. Really doesn't matter what number you choose as long as it's greater than 5, anything to the right of that line. 6 minus 5 is 1, and 6 plus 2 is 8. And when you multiply them, that is 8, and obviously that is greater than 0. So it looks like it's not or equal to, so it looks like it's going to be open circles, and then everything to the right is its solution, and everything to the left is a solution. So there's a couple different ways that we could write that answer. So I'm going to say that x can be anything less than negative 2, or, so this is a union of, it could also be anything that is greater than, actually, you know what, let me write interval notation. Okay, so that would be, so for anything from negative infinity to negative 2, not including, and you never include infinity, or it could also be from 5 to positive infinity. So those are just, so whether you write in equation format, inequality format, or in interval notation, does not matter. All right, so these are the three things you want to look for when you have absolute value. So absolute value of A could equal B. Absolute value could be less than or equal to B, or it could be greater than or equal to B. So in each of these cases, what you're going to see is that with absolute value equals A equals B, so either A is going to equal B or A is going to be equal to negative B. So if let's say A was 5, so absolute value of 5 would be 5 and negative 5. Those are the two answers. So you have x minus 1 equals 4, and then you solve x minus 1 equals negative 4. And whatever your two solutions are, that is going to be your answer. So you end up getting 5 and negative 3. All right, so now when you have, let me change colors. So when you have it less than or equal to, so you're always going to set it up like this. Take whatever the A value is, whatever's in the absolute value, 2x plus 3, which is going to be less than or equal to the B term over here, 15, or it's also going to be greater than the opposite, its inverse, which is this. And I'll show you the reason why this works out later on. All right, so the next thing I'm going to want to do is subtract 3 from all sides, and that ends up giving us negative 18 is less than or equal to 2x, which is less than or equal to 12. All right, now the last step would be to divide all of these by 2, and then you end up getting negative 9 is less than or equal to x, which is less than or equal to 6, and there is your answer. All right, so when it's greater than, then it's just going to be you solve it twice. So you have your absolute value of, okay, so it's missing absolute value of. So we have our 2x minus 1 over 3 is greater than or equal to 5, 6, and then you'll solve it again and say 2x minus 1 over 3 is greater than or equal to negative 5, 6. And then you solve it out for both of these. Now you would multiply both sides by 3, and then add 1, and then divide by 2. I've kind of run out of space, so I'm going to have to move to the next one. All right, so this is an example of our less thans. So if you remember just a second ago, our less than is you take your x minus 3, you put it in the middle. It's going to be less than or equal to 2, but also greater than or equal to the opposite of that b term. And then add 3 to both sides, and to all sides, and there's your answer. So you have 1 is less than or equal to x, which is less than or equal to 5, and there's your solution set. For this one, okay, this is similar to the one that I skipped, so this is greater than, so you have x minus 3 over 2 is greater than or equal to 5, or you have x minus 3 over 2 is greater than or equal to negative 5. So you're just going to simply solve it twice. All right, so scratch that. So one slight mistake. So here we go. We have to flip the sign. So once again, when we change to the negative, you have to change the sign. Multiply both sides by 2, you get x minus 3 is greater than or equal to 10. Over here, you get x minus 3 is less than or equal to negative 10. Add 3 to both sides, and you end up getting greater than or equal to 13, and x is less than or equal to, add 3, negative 7. So there's your answer. So it's either one of these. That's one of those cases where it's going opposite directions. Now, I know I'm running low on my time, so here's what I was talking about a second ago. So when you have that greater than, we know we're talking about answers that are to the right and to the left of those 2 points that you find. And when it's less than, you end up getting answers that are included in between. And then whether or not it's brackets or parentheses is just dependent upon whether or not that it's or equal to or not. All right, and last question. I think I only have 1 minute left, so at least getting it set up. So once again, this is going to be a less than 1, so this is where it goes in the middle. 1 minus 2x over 3 is going to be less than 1, but also greater than negative 1. All right, so the first thing I would do is I'd multiply everything by 3 to get rid of this. So that becomes negative 3. This also has to be multiplied by 3 minus 2x because the times 3 and the divide by 3 cancels. And we end up getting this. Then subtract 3 from everything. So that gives me this. Once again, subtract 3 makes this 0. And then divide everything by negative 2. And I'm kind of, once again, running out of time. So that makes this 3. flip the sign, and divide by is still 0. And there's your answer. And yes, there are only 10 seconds left. Thanks again for watching. Have a great day, and I'll see you in the next video.